All right, so last time we were talking about the investor game, and this was a coordination game. And we learned some things. I just want to recall some of the things we learned so I can highlight them a bit. One thing we learned was that communication can help in a coordination game. So I forget who it was, but someone down here who's disappeared was our Jimmy Stewart character and helped coordinate you on a better equilibrium simply by suggesting what you should do. And this, there's two lessons here. One is this is very different from the prisoner's dilemma. So we learnt the very first time that in the prisoner's dilemma, communication per se won't help. But in a coordination problem, which could be just as serious socially as a prisoner's dilemma, in a coordination problem, it may well help. And the reason it helps is you're trying to coordinate onto a Nash equilibrium. And one way to think about Nash equilibria is that they are self-enforcing agreements. So provided everyone believes that everyone else is going to go along with this agreement, then everyone in fact will. All right? I want to make another slightly more philosophical remark associated with this, and it's to do with the idea of leadership. So leadership is kind of a big word that you see written probably too often these days in too many newspaper articles, and it probably comes up in too many Yale classes. And I don't claim to know anything about leadership, all right? And I don't think game theory is going to contribute anything to understanding about leadership. But one thing we can do is tell you where leadership may help. All right? And in a coordination game, where the idea is to try and get people to coordinate on a particular equilibria rather than on another equilibria, or worse still, to be uncoordinated entirely, in those kind of games, leadership can help tremendously. A little bit of leadership can help tremendously. So these games, these coordination games, are games where there is a scope for leadership. And just to see that in a very simple example, again, we don't need such a complicated example as the one we looked at last time. You could imagine a game, a really trivial coordination game, which looked like this. All right, 1, 1, 0, 0, 0, 0, 1, 1. And clearly, in this game, what matters is coordinating. You either want to coordinate on up left, or you want to coordinate on down right. You don't want to end up, that's a D, you don't want to end up uncoordinated on down left or up right. Everyone see that? So in this game, if you just played it, it's quite likely you're going to end up uncoordinated. But if a little bit of leadership can say, OK, let's make sure this is where we coordinate, or let's make sure this is where we coordinate. All right? So this matters a lot. I don't want to overplay the social importance of this, but go back a couple of years to what was happening in the aftermath of Katrina and realize how important, how bad things get when things fail to be coordinated. All right. One other remark before we leave this. In the game we played last time, in the investment game, one feature of that game was that the more you thought other people were going to invest, the more you wanted to invest. Is that right? The more you thought other people were going to invest, the more likely you were going to invest. And if you go back to the time before that, we talked about this partnership game. In the partnership game, you were contributing effort to a joint project. It could have been a law firm. It could have been working in a study group on a homework assignment. And that game, if you remember what the best responses looked like, they looked like this, where this was the effort of player 1, and this was the effort of player 2. This was the best response of player 1, and this was the best response of player 2. This game also has the feature that the more effort the other person does, the more you want to do. Right? The more effort your partner provides into this project, the more effort you want to provide in this project. And I just want to introduce a bit of jargon here. These games in which the more the other person does, the more I want to do, these are called games of strategic complements. Right? These are games of strategic complements. Strategic complements. All right, so both the investment game and the game with the partnership, the partnership firm game are games of strategic complements. We can call the strategies strategic complements. And we'll come back to this later on today. All right, so before we leave coordination games, I want to look at another one, a little bit more complicated one perhaps, that we mentioned briefly last time. So we'll look at and play another game, and we'll call this game Going to the Movies. All right, so I always regard one purpose of this class to help hapless Yale students in their dating strategies. That seems like a good thing to do. How many of you just, we don't need to show the camera on this, but how many of you are econ majors? There's a lot of people who probably need a lot of help with their dating strategies, right? Right? Okay. So the idea of this game is a couple is going to meet up at the movies, and let's have a look at the movies concerned here. And we'll draw, there's 3 possible movies. All right, well, the movies we're going to look at are The Bourne Ultimatum and the movie called Good Shepherd and a movie called Snow White. And I'll explain the game in more detail in a second. Now, it used to be in the old days before I had kids, I could list off 15 current movies and help you a bit more with your dating strategy by giving you instant movie reviews. But now I have kids, I get to see precisely 2 movies a year. And the 2 movies I got to see this year were The Bourne Ultimatum and The Good Shepherd. And now I think about it, both of those have Matt Damon in it, and my wife chose both, so maybe I need to work out some more. So just to give you some idea about this movie, how many of you saw Bourne Ultimatum? Quite a lot of you. This is a movie, it has pretty good action, virtually no plot. Basic lesson of this movie is, if your take-home lesson, it's that all spies are psychos or something. Right? And then, how many of you saw Good Shepherd? A lot of you saw that as well. It's actually pretty good. It has a lot of plot and no action, so it's the other way around. And the basic lesson of this movie is, and you probably knew this already, everyone at Yale, it takes place at Yale, everyone at Yale is a spy. And by the way, also a psycho. And the third movie is Snow White, which I haven't gone out to see, but my 4-year-old daughter has seen on 24 of the last 27 nights on video. And this movie, I don't know if I'd recommend it that much. Perhaps I'm being too PC, but I'm not convinced that for the modern woman, hanging around waiting for your prince to come is really a good strategy. By the way, for those of you who are, I don't suppose you are, but if you are doing that strategy, I'm going to get in trouble. Never mind. If you are doing that strategy, take it from a Brit. Most princes are as dumb as toast. It's not worth waiting for. All right, so let's put the payoffs in here. So the idea here is that these people are going to move. They're going to meet at the movie. They're going to go out to a movie, and they've decided to go to the Criterion or the local movie house, and there are these 3 movies showing, and they're all excited about going to this movie. Except, being economics majors and not very good at dating, they have forgotten to tell each other which movie they're actually going to go to. Right? They're going to meet in there on the back row probably, and but they're not telling us which movie. So there's a problem, and let's put in the payoffs, and we'll put in the payoffs that roughly I think would correspond to my preferences, and we'll talk about it, what these preferences mean in a second. So here we go. So -1, -1, 0, -1, 0, -2, -2. So here are the preferences for these movies of player 1 and player 2. And you can see from these preferences, from these payoffs, that the best thing for player 1 is for both people to meet and go to the Bourne Ultimatum. This is the action movie. All right, so as not to be sexist, let's assume this is the she and this is the he. So she would like to go and see Matt Damon beat people up and coordinate there. That's her favorite thing. And she gets nothing if they fail to coordinate. And so on and so forth. Her second choice is to manage to coordinate at Matt Damon being a Yale spy. All right, and then she really doesn't want to go and see Snow White. And the worst thing of all, actually this is for both players, the worst thing of all is to coordinate at Snow White, because then you've got to talk about it afterwards at coffee. All right, and similarly for the other person, same thing exactly, except that he would rather meet at the Good Shepherd, since he's a Yale guy, he probably thinks of himself as the Matt Damon character there, or perhaps not, and failing that, he'd like to coordinate at the Bourne Ultimatum, but again, the disaster is to fail to coordinate and go to see different movies. All right? So these are the preferences. What can we tell immediately if you're stuck in this situation? What can you tell immediately about this game? What's an easy first step? Let's get the guy in red here.
Snow White is dominated by both players.
Good. So for both players, Snow White is a dominated strategy. So both players, having taken this class, I told you to help you with your dating, but all right, so both players will realize that they should at least not go to Snow White. Is that right? Right? Great animation, but not perhaps a good date movie. So it's gone. All right, everyone see that? So that leaves us just with these two options. The two Matt Damon movies, Bourne Ultimatum and Good Shepherd, and here are the remaining payoffs. And let's see how we play this out. So let's pick on some people. Ali, you want to pick on somebody? I'll get Kai to pick on somebody as well. All right. All right. So okay. So we picked on somebody there. When you the person who Ali picked on, you want to stand up? Okay, and your name is?
Nina.
Say again, loudly.
Nina.
Aina.
Nina.
Just shout it out so everyone hears. Aina. And Kai, did you pick on a guy? Nina.
Nina, yeah.
Nina? Okay, Nina, I'm sorry, Nina. And Kai, get your guy to stand up there. And your name is?
David.
David. So do you know each other?
No.
No? Okay, so you're about to go on a date. So this is a bit, okay, so. All right, so Nina's preferences are player one's preferences here. So her best thing now is to successfully meet David at the Bourne Ultimatum, and David's preferences are player two's preferences, so his favorite thing is to successfully meet at the Good Shepherd. And why don't you write down a second on the corner of your notepad what it is you're going to choose to do. With my TAs watching you, so you really can't cheat. All right, both written down. All right. Can we have a good look at them so we just embarrass them a bit? We've looked at them already, I guess. Okay. So Nina, shout out to the crowd what it is where it is you've chosen to go.
Bourne Ultimatum.
Bourne Ultimatum. And David, where did you choose to go?
I also put down Bourne Ultimatum.
So they're going to coordinate. It's been very good. All right. So I don't know what this tells us about David and Nina, but don't let them off the hook quite yet. So now, that was good. We managed to coordinate, although I think we can all see that we might not have done, right? We all see we might not have done. All right, let's try some communication in this game. We said that coordination games are helped by communication, all right? So let's imagine we're playing the game again. Once again, you're going to the movies. Once again, the first time didn't happen, so for some reason it was cancelled that night. Someone had a bad cold or something, and you are about to go off on Friday night to see these movies. And let's allow some communication ahead of time. So David, you're about to go, you realize you've got this coordination problem, so you phone Nina up and you can say whatever you like. So what would you say to Nina?
Looks like you want to go to Bourne Ultimatum. I'd rather go, and if you're going to be stubborn, I'd rather go see Bourne Ultimatum with you than not go on a date at all.
So here's another clue. Stubborn is not a good first date word. All right, but okay. So Nina, what would you say in response to that?
I'll go to Bourne Ultimatum.
All right. So write down what you're going to do this time. All right, and Nina, what did you do?
Bourne Ultimatum.
David?
Bourne Ultimatum.
So they're still managing to coordinate, but you can, okay, so thanks for this couple. Let's give them a round of applause. We may come back and pick on you later on in the course, but we'll leave it for now. All right, so in this case, the communication worked, all right, but am I right in thinking that the communication isn't such an instant solution as it was in the game we saw last time? This game's a little bit harder to get communication to work. Now, why? I mean, is that right, first of all? So what's the problem here? Why is this a slightly more difficult game? Let's keep the mics handy a second. Why is this a more difficult game to attain coordination in? Yeah, that's the, can you?
Neither of the best responses is a Nash equilibrium.
Well, no, hang on a second. So let's slow down a second. That's a good one. Let's start with that. What are the Nash equilibria in this game? What are the Nash equilibria in this game? So, somebody, let's pick on somebody. Just pick on anybody, okay? Yeah, what are the Nash equilibria in this game?
Both players doing Born Ultimatum and both players doing Good Shepherd.
All right, so in fact, if we check the Nash equilibria in this game, the Nash equilibria, you can check that they are in fact best responses, are both people doing the Born Ultimatum or both people doing the Good Shepherd. And the reason for that is if the other person's going to go to Born Ultimatum, I want to do that. And if the other person's going to go to Good Shepherd, I want to do that. So these are both Nash equilibria. That isn't so much the problem. That was true last time as well. There were two well-coordinated Nash equilibria, although one of them was better than the other. What's the tricky thing here? What's the extra trick here? Somebody, yeah, is there a camera? Do we have a mic on this side? Sorry. There was a hand up there. Yep, go. There you go. Stand up. Great.
Each player prefers a different Nash equilibrium.
All right, so unlike the other game, the two examples of coordination games we saw so far were really pure coordination problems. Is that right? They were pure coordination problems. There was no conflict at all. In the case of the investor game last week, every player preferred one equilibria to the other. Right? In the game I just put up, the sort of trivial example, it didn't really matter which equilibrium we played here. We just wanted to play an equilibrium. Is that right? Is that right? But here, there's a potential source of conflict here. Both people would rather be at an equilibrium than to be mal-coordinated or uncoordinated, but player 1 wants to go to Born Ultimatum and player 2 wants to go to Good Shepherd. And actually I thought Nina's strategy there was pretty good. Nina's version of communication was, I'm going to Born Ultimatum. Right? And that basically fixed things. Right? But you could imagine that communication could break down here. There could be a negotiation going on. All right? So think about, I mean, I don't want to push this too hard, but think about other games where people are communicating to avoid a failure of coordination. There's a strike negotiation going on as we speak. In fact, there's a critical moment this morning up in Detroit between General Motors and the United Auto Workers. And I don't want to say that strikes are only about miscoordination, but clearly everyone's better off if they come to some agreement rather than strike. There's at least some agreement that's going to be better for everybody than a strike. And yet, because there are conflicting interests there, basically in that case, conflicting interests about health and pension payments, it could well be that you end up failing to coordinate. All right, so this game has a name, and actually somebody mentioned it last time. Anyone, who's the person who mentioned this last time? Somebody mentioned this. What's this game called? Yeah, shout it out. Battle of the Sexes. That's good. So this game's called the Battle of the Sexes. And we'll see it in various forms over the course of the semester. It's actually a very interesting game. Games like it, they are coordination games, but different people disagree about where you'd like to coordinate. All right, so much for talking about coordination games and helping you with your dating strategy. This being a game theory class, there's at least one game we have to discuss, and we'll come to it now. So we're going to spend most of the rest of today talking about cornoduopoly. And before I do that, let me just check. How many of you have seen cornoduopoly before? Just raise your hand, just for me. All right, so maybe about half of you. So those of you who have, don't worry, I mean, this will be a bit review, but we'll see it more through the eyes of game theory this time. And for those of you who haven't, don't worry, we're going to go through it, okay? Okay? So this is a classic game, perhaps it's one of the most famous games, and therefore worth studying in the class. Now, as a purely game theory exercise, one reason for studying cornoduopoly is that so far we've discussed how to find Nash equilibrium when there are few players, each of whom has few strategies. And we've discussed how to find Nash equilibrium where there are many players, each of whom has few strategies. And this is a game where there are few players, namely 2, but they have many strategies. All right, they actually have a continuum of strategies. All right. For those people who aren't familiar with this and are worried about the economics of it in particular, it's gone over in considerable detail in chapter 6 of the textbook. In chapter 6 of the textbook. Of the data book. All right. So let's just motivate this a little bit. So there's two reasons why this game is interesting. So I should say what it is. So this is a game in which there are two firms who are competing in the same market. And we'll give a bit more detail in a second. And one reason this game is interesting from the point of view of economics is this game lies between the two extreme cases that you learn about in your intro economics class. One extreme case is perfect competition, and the other extreme case is monopoly. So this is really the first attempt, way back in the 19th century, to study a market that's somewhere in the middle, where in fact most markets are. All right, there are two firms. And we're interested in two things here. We're interested in what's going to happen in these markets. And then from a welfare point of view, from a policy point of view, we're interested about whether this is good for consumers or good for producers or what. Right? How this relates to profits and consumer surplus. All right, so with that in mind, let's just set the game up. So the players in this game are two firms. Two firms. And the strategies in this game for the firms, and this is going to turn out to be important, the strategies are the quantities that they produce of an identical product. All right? So they are the quantities they produce, or each of them produces, of an identical product. So as far as the consumers are concerned, these two products are perfect substitutes. You could think of these as two companies producing bottled water. And now I'm going to get hundreds of letters saying not all bottled waters are the same, especially from Italians and the French, but never mind. Let's pretend that they are. All right? So just to emphasize that the strategies are quantities, rather than using S, let me use Q today to be the strategies. So QI and Q minus I, or Q1 and Q2 will be the strategies. All right? Now I need to give a little bit more structure on the payoffs before I get to the payoffs. So in particular, I need to tell you what is the cost of production. And the cost of production in this game is simply going to be C times Q. All right, so if I produce 1 unit, it costs me C. If I produce 2 units, it costs me 2C. If I produce 100 units, it costs me 100C. And if I produce 0.735 units, it costs me 0.735C. And so on. All right? So for those people who took intro economics, which is most of you, this is a game, or this is a setting in which we have constant marginal costs. Constant marginal cost. The constant marginal cost is C. All right, and I'll need to tell you about how prices are determined in this market. So prices are determined as follows. Prices depend on some parameters I'm just going to call A and B. And let me write the equation and then we'll see what it looks like. So basically the idea is that the more these firms produce, so the more is the total quantity produced, Q1 plus Q2, the lower is the price in the marketplace for this product. All right? And let's just draw a picture of that. We'll come back to this in a minute. Let's draw a picture which we can keep for later. Actually, let's save myself some time and bring this down. All right? So this equation I've just written, you can imagine Q1 plus Q2, total quantity on the horizontal axis, and you could imagine price on the vertical axis. And basically what we're saying is that prices depend on total quantities as follows, where the slope of this line is minus B. All right? Now for those of you who took Economics 115 or equivalent, what is the name of this line I've just drawn? Okay, that was way fewer responses than I wanted. All right, let's try again. What's the name of this downward sloping, hint, hint, line that I've just drawn? It's a demand curve. Thank you. It's a demand curve. All right. This is the demand. It tells me, if I look at the other way around and look at how prices correspond to quantities, it tells me the quantity demanded at any given price. All right? We'll come back to that in a second. But meanwhile, let's just finish up what we're doing here and put in payoffs. So payoffs for these firms are going to depend on profit. So the payoffs, the firms aim to maximize profit, and profit is going to be given by P times Q minus, sorry, let's do this for firm 1, all right? Let's be careful here. Let's do this for firm 1. I'll do firm 1, firm 2 in a second. So the payoff for firm 1, as it depends on the quantity that she produces and the quantity that the other firm produces, is going to be prices times the quantity that firm 1 produces minus costs times the quantity that she produces. All right? All right. So this term here is revenues. This term here is revenues, and this term here is total costs. Right? Revenues minus costs makes profits. And again, for those people who are less familiar with economics, I'm hoping this is not going to be too hard, but you can read up on it otherwise. All right? And what I'm going to do here is I'm going to substitute in for prices. All right? So I've got this expression for prices here. Here it is. And I want to plug it into that P there. Okay? All right? So I'm just going to rewrite it now with that P expanded out. All right? So I'm going to get, and I'm going to multiply out at the same time. So I'm going to have A Q1 minus B Q1 squared minus B Q1 Q2 minus C Q1. Right, so all I'm doing here, nothing particularly exciting. I'm simply plugging this expression in for P, and then I multiplied the whole thing out because it was all multiplied by Q1. And I should warn you again that I'm very likely to make mistakes when I'm doing this kind of thing, so please catch me if I do. All right? So here I have a new expression for firm 1's profit, and I could do the same for firm 2, but I'm not going to because that would get boring. Okay? All right, so this is just firm 1's profit. Okay, now with this in hand, what I want to do is, I mean, firm 2 have a similar expression. What I want to do is, I want to figure out the Nash equilibrium of this game. Right, now I will need the other board. I want to figure out the Nash equilibrium of this game. Both firms are producing quantities. Both firms are trying to maximize profit, and I want to find out the Nash equilibrium. How do I go about that exercise? What do I need to do to find each firm's Nash equilibrium? How do we always find Nash equilibrium when we're not guessing? What do we do? Anybody? Somebody way over there who's going to be way off camera, but perhaps we can get a mic in there. Can we get him? Sorry, he's way in the corner there. Come this way along so a bit closer to the aisle. There you go.
Well, we would just delete the, we would iteratively delete dominated strategies.
Okay, we could do that. We could try iteratively deleting dominated strategies and see if that process converged. I had something else in mind here, something that's more straightforward. What else? So the guy in red?
Identify the best responses of each player as a function of the others and find out where they intersect.
Okay, say that more. That was correct. Let's say it more loudly. Shout.
Identify the best responses of each player as a function of the others and find out where they intersect.
Okay, good. So what we're going to do is we're going to figure out player 1's best response quantity to each possible choice of player 2, and then we're going to flip it around and figure out player 2's best response quantity to each possible choice of player 1, and then we're going to see where those coincide, where they cross. All right, so just like we've done several times before. All right, so what I need to do then is I need to figure out what is player 1's best response for each possible choice, Q2, of player 2. All right, so how do I do that? How do I do that? I want to find the best response. How do I do that? Everyone's looking like this is, but I bet you all know, really. Anybody? Do you want me to cold call somebody? No. Ah, somebody, yeah. Sorry, mate, it's athletic day for you. Somebody way at the back there. Sorry. Stand up and shout.
Find the best response function by differentiating this and maximizing the function for every Q2. So
okay, good. So what we're going to do is, all right, good. We're trying to maximize, but the best response is going to maximize these profits. All right, so in particular, what we're going to do to find out what quantity Q1 maximizes this profits for each choice of Q2, we're going to differentiate this with respect to Q1, and then what? And then set it equal to 0. Okay? So again, let me just take a look out there. How many of you remember this? We did this once before I did this class. How many of you remember this from your high school calculus days or from 112? Yeah, quite a number of you actually remember it. Okay, good. So what we're going to do is we're going to differentiate this thing to find a first order condition. We're going to differentiate with respect to Q1, right? The thing we're trying, our control variable, the thing we're trying to maximize the thing with respect to, and set it equal to 0. All right, so what I'm going to get. So this term here, AQ1, is going to become an A. And this term here, minus BQ squared, is going to become a 2BQ1. And this term here, minus BQ1, Q2, is going to become a minus BQ2. And the last term, minus CQ1, is going to become a minus C. All right, everyone happy with that? So what I did was I differentiated this fairly simple function with respect to Q1. And since I want to find a maximum, what I'm going to do is I'm going to set this thing equal to 0. All right, so at my maximum, I'll put a hat over it to indicate this is the argmax. At my maximum, I'm going to set this thing equal to 0. Now, but just since we're being nerdy in this class, despite our attempts to go dating, we're being nerdy, let's actually be a little bit careful. This was a first order condition, or a first order necessary condition. I actually need to check the second order condition. So how do I check the second order condition? I differentiate again, right? I differentiate a second time and check the sign. So the second order condition, I differentiate this expression again with respect to Q1. The only place Q1 appears here is here. So when I differentiate again, I'm just going to get minus 2b. And sure enough, that's negative, which is what I wanted to know. That's just to check that when I'm finding this thing, I'm finding a maximum and not a minimum. All right, good. Good. OK, so this is our key expression. And I'm going to use this expression. I'm going to solve it for Q1. So the best response for player 1 as a function of what player 2 chooses, Q2, is just equal to the Q1 hat in this expression. And if I solve that out carefully, I will no doubt make a mistake, but let's try it. I'm going to have A minus C over 2b minus Q2 over 2. All right, so try that at home. But I think I did that right. So I took this to the other side, and I divided through by 2b, and the b here cancelled. All right, everyone just stare at that a second, make sure I get it right. I'm very, very capable of getting these things wrong. All right, good. So what I have here is an equation that tells me player 1's best response for each possible choice of player 2. All right? And I could do the same thing for player 2 to find player 2's best response for every possible choice of player 1. On the other hand, we know the math is going to be the same. So let's cheat. I know that player 2's best response for every possible choice of player 1, which if we'd done it would be Q2 hat, is going to equal A minus C over 2B minus Q1 over 2, right? So I'm just flipping around the 2's and the 1's. So at this point, I found player 1's best response as a function of Q2. I found player 2's best response as a function of Q1. And the way I did it, just to remember, the way I did it was I applied a little bit of 112 and or high school calculus, right? Essentially single variable calculus. All right. Now, before we could just solve at this point, but it's not. Let's draw these. Let's draw these, okay? So what I'm going to do is I'm going to go back to my picture and draw these functions. I'll just remind ourselves what these functions are. It's A minus C over 2B minus Q2 over 2, and equivalently for player 2. All right, that's the thing. It is hidden by the board now. What I want to do is I want to draw a picture a little bit like we did for the partnership game. So in the partnership game, we put efforts on these axes, and now I'm going to put quantities on these axes. So this is going to be the choice of player 1, and this is going to be the choice of player 2. And what I want to do is I want to figure out what this looks like. For each Q2 that you give me or that player 2 chooses, I want to find out and draw what is player 1's best response. All right, everyone happy with what I'm doing here? All right, so let's start somewhere. And what we're going to do is we'll refer back to this other picture, which is why I left it here. All right, so in particular, what would be player 1's best response if player 2 didn't produce at all? How would we find that? Without worrying about the economics of it a second, how would we find that just as a math exercise? So suppose player 2 doesn't produce at all. All right? What is player 1's best response? Someone read it off for me? When we cold call somebody, Ali, you can just...
A minus C over 2B.
All right, so shout that out.
A minus C over 2B.
Good. So if I plug Q2 equals 0 into here, this term disappears, right? And I just get A minus C over 2B. So what's that telling me? Let me put the 45-degree line in here. What's that telling me? It says if player 2 chooses not to produce, then player 1's best response is A minus C over 2B. Now I claim that that quantity, A minus C over 2B, actually has another name. What's the name of that quantity? What's the name of the quantity A minus C over 2B? Once we escape the algebra and just think about it in terms of economics. Well, let's think about it a bit. Let's go back to the previous picture. If player 2 is producing nothing, then what is player 1 effectively? He's a monopolist, or she's a monopolist, all right? So we know how to figure out monopoly quantities from what we did in 115, or equivalent courses. Let me finish the picture here. Here's my demand curve. Here's my constant marginal cost at C. All right, I want to use this picture on the left now to figure out what the monopoly quantity is. Can anyone tell me, let's cold call somebody again. Raise your hands if you took 115 or 110 or 150. Oh, no, I know more of you took it than that. It's a prereq for the class, right? Raise your hands if you didn't take any of those things. All right, so Alec, keep your hand up. Cold call somebody who hasn't got their hand up. Anybody, go ahead. We're passing the back here. Do you want to tell me where's the monopoly quantity on this picture? Try the woman there. Try the woman one in. Yeah, that's where you are. The woman here. Yeah.
Oh no, I really don't remember.
Don't remember? Don't remember? Who else doesn't remember? Who else? Somebody must remember. Don't remember is a good reply if you're auditioning for it to be the Attorney General, but it's not such a good reply. Anybody? Somebody help me out here. Where's the monopoly quantity on this picture? a good review exercise, this. Yeah?
It's where the marginal revenue is equal to the marginal cost.
Ah, it's where marginal revenue equals marginal cost. I should have picked on one of the SOM people, by the way. It's where marginal revenue equals marginal cost, right? The reason I should pick on the SOM people is their ambition in life is to run a monopoly, right? So, all right? Trouble is, I haven't drawn the marginal revenue curve yet, right? You can't actually see the marginal revenue here. What does the marginal revenue look like in this picture? I don't go to the same guy, the guy in brown. Where's the marginal revenue what's the marginal revenue look like in this picture on the left?
It's 1/2 the slope of the price.
Yeah, or I guess it's twice the slope, but that's fair enough. I know what you mean. All right, so the marginal revenue here, let's put it in a different color. The marginal revenue looks something like this. Right, and as, I don't know what your name is, as the guy said, the monopoly quantity is when marginal revenue equals marginal cost. All right, and as we know, this line here has twice the slope of the original line of the demand curve, so the slope of this thing is minus 2b. All right, now I'm going to claim that this monopoly quantity I claimed before is going to our intuition says if the other firm isn't producing, my best response must be to produce my monopoly quantity, which I can see on this picture. And I also claim that the math is telling me, just a kind of nerdy math is telling me, that that quantity is A minus C over 2B. And I claim that they're the same thing. How can I see they're the same thing? Well, look, here I have a line of slope minus 2. How far down does it have to go? It has to go A minus C down. This pink line has to drop off from A all the way to C. How far along do I have to go to drop off A minus C when I have slope minus 2b? Answer A minus C over 2b. Right? That's not even calculus, something you really all did at high school. All right? Okay, so this monopoly quantity is indeed A minus C over 2b. All right? And I'm going to ask again, is some of this coming out of the fog? I mean, you may not have seen it with the algebra before, but some of this sort of pictures have you seen before? It's good review exercise for some of you who have taken 150 and are about to take 150 or are there now. All right, so we found precisely 1 point on this best response picture, and there's a lot of points to find, and it's 12:20, so we better get going. All right, so let's try and find another point. All right, let's ask a different question. How much quantity would firm 2 have to produce in order to induce firm 1 not to produce at all? Say it again. How much quantity would firm 2 have to produce in order to induce firm 1's best response to be 0? All right, Ali, help me out. It's Katie, right? Is that right? The woman in green. Let's get a mic to Katie. Oh, there's a mic closer by. Oh, never mind. Sorry, Anne. Yeah.
A minus C over 2b.
All right. So that's just solving out the algebras. We're saying what Q solves A minus C over 2b minus Q2 over 2 equals 0. Right. What Q2 makes this equal to 0, and Katie's answer is, solving out the algebra here, is that Q2 that solves this must be A minus C over B. All right, that's right. Where can I see that one on the picture, though? Let's go back to the economics. Right, so I'm claiming that there's some quantity up here. I claim this quantity is A minus C over B, such that if firm 2 produces that much quantity, firm 1 will just produce nothing. All right? But that's just kind of algebra and math. Where can I see it on this picture? What quantity, if produced by firm 2, would cause firm 1 to shut down on this picture? Yeah, let's get a mic in here. Sorry again.
That's where the marginal cost and the demand lines intersect.
All right, so it's here, right? It's here. It's where the marginal cost and the demand curve intersect. And what's the intuition? Well, let's work it out. Suppose firm 2 has produced all of this quantity up to here. All right, so firm 2 is already producing all of this quantity. So already, just from firm 2's production, the price has been driven all the way down to costs. All right? So if I'm firm 1, if I produce any more quantity, what's going to happen to the price? If I produce any quantity at all in addition to what's out there already, what's going to happen to the price? It's going to be pushed below costs. All right? So I'll be producing this stuff, this water, at cost C, and only getting P, which is now going to be less than C, in return. So I'll be losing money on any product that I produce. Everyone see that? Let me say it again. So if firm 2 produces all the way up to here, then any product produced by firm 1 is going to push prices even lower. In particular, they'll be lower here than costs, and so you'll make losses on that product. All right? What's the name, going back to Economics 115, what's the name for this quantity? The quantity where demand and marginal costs equal? That's the competitive quantity. All right? So this is the perfect competition quantity. In a perfectly competitive market, that's exactly where prices are going to end up. This is not a perfectly competitive market, but if it were, that's where prices are going to end up. All right? So we have the monopoly quantity here, and we have the competitive quantity here, and in between, what does this best response curve look like? Somebody? It's a straight line. It's a straight line. Thank you. All right, so in between, this is just a straight line. All right, so here is the best response of firm 1 to each possible choice of firm 2. All right, everyone's looking really like this was hard, but it can't be that hard. You've seen it, most of you have seen this before. All right, so if you haven't seen it before, don't panic. All I did was I did a little bit of calculus, a little bit of algebra, and then I drew the thing. I just drew the thing. All right. Okay, so this is firm 1's best response as a function of Q2. What is firm 2's best response as a function of Q1? Just before we get there, just to remind you, the way we read this is you give me a quantity of firm 2, I find firm 1's best response by going across to the pink line and dropping down. So if firm 2 produces this amount, then firm 1's best response is this amount. If firm 2 produces this amount, then firm 1's best response is this amount. All right? Now conversely, how do we find firm 2's best response as a function of Q1? What does that look like? Yeah, do you want to get the two guys in front of you?
It's
Shout it out.
symmetrical. It's symmetrical across the 45-degree
All right, it's reflected across the 45-degree line. So let's reflect these 2 points. This will be here, and this will be, I'll be a bit more careful. I missed by a mile. Let me just try again. I missed by a mile, which is a problem in drawing my lines, but never mind. All right, so this will be the monopoly quantity for firm 2, and this is the competitive quantity for firm 1. All right, so if I'd drawn that better, it would look as if this was half of this distance. Right, but I didn't draw it well. Try and draw it better in your notes. All right? All right, so this is A minus C over B, and this is A minus C over 2B. So this distance and this distance are meant to be the same, and the way I've drawn it, these don't look the same at all. All right. And the way we read this green graph is you give me a choice of firm 1, Q1, I go up to the green line and go across, and this tells me the best response for firm 2. All right. So at this point, how many of you have seen this picture before? Good many of you have seen it before. All right. So I think we can really cold call somebody for this one. All right. So somebody tell me, and pick some time to cold, when you cold call somebody, anybody can close by. There we go. Okay, okay. So here's the tough question. what's the Nash equilibrium on this picture?
Where the green and the pink line intersect.
All right, where the green and the pink line intersect, all right? All right, so this must be the Nash equilibrium. All right, that wasn't hard, right? Okay, okay. All right. Now, okay, so why, well, let's go back again. Why is this the Nash equilibrium? Because at this point, as in the partnership game, we saw a similar thing. As in the partnership game, where the best responses intersect is where player 1 is playing a best response to player 2, and player 2 is playing a best response to player 1. So this is the Nash equilibrium in this Corno game. All right, let's do a little bit of algebra just to make sure we can find this thing. All right, so what we're going to do is set these two things equal to each other. Put in stars here. So at the Nash equilibrium quantities, I shouldn't really do this, but never mind. At the Nash equilibrium quantities, I'm going to have Q1 star is equal to A minus C over 2B Q2 star, etc. And Q2 star is equal to A minus C over 2B Q1 star over 2. All right, and now I'm going to solve this out by setting Q1 equal to Q2. Since I know the game is symmetric, I know we're on the 45-degree line. All right, so what I have to do here to do this algebraically is to solve out these equations. So let's try and do that. So putting Q1 in here, right, if I substitute Q1 in here, what will it give me? It'll give me Q1 star is equal to A minus C over 2B minus Q1 star over 2. Let's multiply both sides by 2. I'll get 2 Q1 star is equal to A minus C over B minus Q1 star. Take that to the other side. I have 3 Q1 star is equal to A minus C over B. And finally, divide by 3. Q1 star is equal to A minus C over 3B. All right, so that crossing point actually occurs at A minus C over 3B. And again, I'm going to look desperately at my TAs, check I didn't screw that up. I think I didn't screw that up. All right, so this is sometimes called the Corno quantity. Now this game of imperfect competition between two firms competing in quantities was thought up and studied by a French economist called Corno almost 100 years before Nash. Right? So 100 years really before the invention of game theory. Right? Someone had figured out this answer for this game. All right. Okay, so what do we know so far? I'll leave the algebra there. Transfer it up here. Q1 star equals Q2 star equals A minus C over 3B. All right. So far we've been working pretty hard, and we haven't, I guess, learned a lot. We just kind of solved the thing out. Now we get to draw some lessons out of this thing. All right, so everybody who's feeling a little bit shell-shocked from having been doing algebra and calculus and drawing pictures and feeling like they've been cheated into taking a class that looks far too much like economics, calm down. We're going to actually talk about it now, okay? All right. So one thing to remark about this game, one thing we've learned immediately, is that this game is different in a significant way. It's different from the partnership game. I mean, obviously it's different because it's about something different, but I mean, in terms of the game theory, it's different. It's different from the partnership game. It's different from the investment game. What is it that's different about this game from the what's the obvious thing, just looking at this picture, that makes it different from the partnership game? In the partnership game, the best response lines sloped up. Is that right? The more I did of my strategy, the more the other player did as a best response. In the investment game, the more likely I was to invest, the more you wanted to invest. All right? But in this game, we have the exact opposite. The more player 1 produces, the less player 2 wants to produce. and the more player 2 produces, the less player 1 wants to produce. All right? So this game is a game not of strategic complements, but of strategic substitutes. And I want to be careful here. It's not that these goods are substitutes. I mean, clearly that's also the case, right? If both these firms are producing bottled water and it's identical, right, then the goods themselves are substitutes. That's not the point I'm making here. Strategic substitutes is a statement about the nature of the game. So strategic substitutes is telling me that my strategy is a strategic substitute of your strategy if the more I do of my strategy, the less you want to do of yours, and conversely, the more you want to do of your strategy, the less I want to do of mine. All right? Okay. Now let's come back to the question we started with, which is to do with profits and so on in society. We know that if these players play these games, at least if we believe in Nash equilibrium, then they're going to produce these quantities. They're going to produce here. All right? But let's ask a different question. Each of these firms is trying to maximize profit. All right? But how about the total profit in the industry? Right? So each of these firms, we know by the fact they're playing a best response, is maximizing their profits, taking as given what the other firm's doing. But how about total industry profits? Are they being maximized here? Who thinks total industry profits are being maximized? Who thinks total industry profits are not being maximized? All right, good, good. So shout out. Okay, so total industry profits are not being maximized. Where on the picture, let me get another bit of cold calling in here. Where on the picture maximizes total industry profits? Where on the picture maximizes total industry profits? We had him before. Someone else. Yeah. No idea? No idea? People taking the fifth here? Yeah, the guy in there. Yeah.
Is it at the monopoly?
At monopoly, exactly. So clearly, if we produce the monopoly quantity, by definition, the monopoly quantity maximizes total industry profit. So, for example, if firm 2 shut down and firm 1 produced its monopoly profits, its monopoly quantity, that would maximize firm profits. And conversely, if firm 1 shut down and firm 2 produced its monopoly quantity, that would maximize industry profits. All right. Where else on this picture maximize industry profits? So this point maximized industry profits, and this point maximizes industry profits. Where else maximizes industry profits? Anybody? Well, how about all the points in between? Here, firm 1 produced nothing, and firm 2 produced the monopoly quantity. And here, firm 2 produced nothing, and firm 1 produced the monopoly quantity. But you could also just split the monopoly quantity, for example, half-half, at this point here. All right? So if the firms wanted to make more money, one thing they could do is they could sign an agreement saying, why don't each of us produce not our Cournot quantity, but produce half monopoly profits. Sorry, half the monopoly quantity. And that would produce this much each. All right, so firm 1 would be producing half its monopoly quantity, and firm 2 would be producing half its monopoly quantity. All right, so what's wrong with that agreement? So here they are. What are they? They're 2 water companies, so they're Poland Spring and Coca-Cola, I guess, these days, have signed this agreement saying that each one's going to produce half monopoly quantity. And what's going to go wrong with that agreement? Yeah, the guy in red.
First of all, it's illegal.
It's illegal. It's illegal, right? So even without there being an attorney general, somebody might be awake in the Justice Department and notice that that's actually illegal. All right? It's illegal to sign an agreement, to sign a contract saying you're going to restrict quantities. It's illegal, so they can't sign that as a contract, but hey, they could just agree to do it. Right? So Coca-Cola and Poland Spring could just agree to produce half the quantity of water each. All right? What's going to go? What might go wrong in that agreement? Let's just suppose that that game's just being played once for now. All right? And suppose that this is Coca-Cola's quantity, and this is Poland Spring's quantity. And suppose you're the manager of Poland Spring, right? So water is coming out of the ground in Maine for you, all right? And you know that this Coca-Cola guy is going to produce this quantity here, all right? So this is QM over 2, QM over 2, all right? So let's pick on our two managers. Let's have two people who've spoken before. So the guy in the red shirt's name is Steve, and I guess in red he should be the Coca-Cola guy, all right? All right, and let's pick on our Jimmy Stewart from last week, whose name is Patrick, right? Can I get a mic on Patrick, all right? All right, so Steve and Patrick are respectively the managers of Coca-Cola and Poland Spring, and here he is, right? Right, and Patrick believes that the Coca-Cola manager is going to, maybe we should just make this Coke and Pepsi's. It's two identical, they're near enough identical, all right? So these are Coke and Pepsi. That'll confuse me less. All right, so Patrick, our manager of Pepsi, believes that Coca-Cola is going to produce this quantity, and he's agreed to produce this quantity. What is Patrick actually going to do? Patrick, what are you going to do?
So I should cheat and pick the quantity on my best response line that's much farther out, so I'll produce more than that quantity. All
right, so Patrick, being Jimmy Stewart or not, actually when he's when he's playing the manager of Pepsi, is going to produce more of this undrinkable liquid and produce this quantity here. All right, so what is this? This is Patrick's best response to the other guy producing the monopoly quantity. All right? All right, so Patrick's response in Pepsi is to overproduce relative to the monopoly quantity, actually overproduce even relative to the Cornell quantity, right? And produce all the way out here. Okay, so Patrick's producing here. But what about Mr. Coca-Cola guy? All right? Now, Mr. Coca-Cola guy knows Patrick pretty well. But, they've been in the same industry for a while. And Mr. Coca-Cola guy's name is Stephen. Stephen presumably knows that Patrick is actually going to produce this quantity. Sorry, this quantity. So, Stephen, what should you produce?
Increase my own production to match my best response line.
Good. So Stephen, anticipating that Patrick is going to think that Stephen's a sucker, but Patrick's going to cheat on him and produce too much, Stephen's going to produce a best response to that, and he's going to produce this quantity here. So what is this? This is player 2's best response to player 1's best response to player 2 producing half monopoly output. All right? But Patrick knows Stephen pretty well, and he knows those guys who run Coca-Cola are pretty smart guys. So Patrick knows that the guy who runs Coca-Cola is going to anticipate that the guy who runs Pepsi is going to cheat on the guy who runs Coca-Cola, and hence the guy who runs Coca-Cola is going to play a best response to Patrick's cheating quantity. So what quantity is Patrick going to produce?
So I reduce my production then, and I'll end up pretty close to the Cornell equilibrium.
All right, so you're going to go to here. So this point here is, I don't even write this, this is the best response of player 1 to the best response of player 2 to the best response of player 1 to player 2 producing half monopoly output, and there's lots of brackets here. All right? And can anyone see where this process is going? Anyone see where this process is going? Right? It's going back to the Nash equilibrium. Right? Each of them is trying to play a best response to what they anticipate the other person's going to do. And in this game, if they keep on doing that, it's going to drag them back to Nash equilibrium. I want to be careful here. This won't be true of all games. But in this game, playing best response to each other, figuring out that in fact the other guy is going to cheat on me, or the other guy is going to anticipate that I'm going to cheat on him, or the other guy is going to anticipate that I'm going to anticipate that he's going to cheat on me, etc., will eventually drag us back to the Corno quantity. All right? So it's going to be pretty difficult for us to sustain this joint monopoly output, this collusive agreement. We can't let the courts enforce it. We're Coca-Cola and Pepsi, so we really don't want to bring the mafia in, although maybe we do, I don't know. All right, so basically, we're stuck with this verbal agreement, and we both have an incentive to cheat and produce more, whatever it is, sugar water. All right? Okay. Now, in practice, this is not the only problem facing two firms who are trying to produce the monopoly output. Right? In practice, when firms try and have these agreements, which are not contracts, to try and produce joint monopoly output, what else goes wrong? What else goes wrong? So you could imagine some firms trying to have an agreement. We know they can't sign a legal agreement, but let's take that off the table. So, for example, in around 1900 in America, or a little bit earlier, let's say 1880 in America, it really isn't clear that it was illegal to write agreements to say we'll restrict quantities. Right? So firms did used to write that kind of agreement, but still something went wrong. What went wrong? So we're getting a little bit further away from the game and more back into the real world now. What kind of things went wrong? I want to get somebody who's nearer a mic. Can I get the woman here, the Yale shirt?
Without a contract, there's no means of enforcement.
All right, so it might be that, again, that there's a problem with enforcement, although actually in 1880 in America, it's not clear that they couldn't have enforced that contract. All right, so one problem is unenforceability, right? But that might, far enough ago, that might have been a problem. What else? The guy next to her, yeah?
If they're not at the competitive output, they could undercut price and take the entire market.
Let's be careful. We'll come back to that next time. But right now we're competing in quantities, all right? So we're not fixing prices here. We're not even naming prices. We're just producing Coca-Cola and Pepsi and, for want of a better word, spewing it out into the market. All right? What else goes wrong here? Well, one thing that goes wrong is that suppose Coke and Pepsi were able to either to write a contract or whatever to sustain joint monopoly output at this high price, this price which is, producing positive profits in the industry. It is going to turn out, therefore, that prices are going to be above costs. These firms are making a lot of profits. What do you think is going to happen in this industry? This industry that's got a lot of profit around it. What's going to happen in this industry? Yeah, the guy in the blue shirt here. Ali, this guy here.
Another competitor could join the market.
All right, another firm is going to come in and produce a similar product. So Dr. Pepper or something, is that the third one? Someone else is going to come in and produce cola in this industry. And that's exactly what happened in the US at the turn of the last century. Companies did produce agreements to restrict, for example, the production of paper and the production of rubber and the production of steel and the production of iron and the production of railway lines, actually, in quite complicated things. And sure enough, what you see very quickly emerging is new entrants entering the market to say, hey, these firms are restricting their quantities, we can get in there and make money. All right? So a competitive fringe of firms is going to enter and drive prices down. Now, I talked about that in 1900 America, whereas that happened in the 20th century more dramatically. So we know the early example in sort of golden age America, but where else did we see a competitive fringe enter when there was a collusive agreement to keep prices, keep quantities down? Airlines. So airlines, okay, good. So airlines is an example. We've seen that. Where else? Oil is probably the classic example. Airlines is a good example. Okay. So in oil, we all know that in the late 60s, early 70s, OPEC was formed precisely to restrict quantity among the major oil-producing countries, and very quickly we see companies other countries take advantage of this to start producing oil profitably. So who were the competitive fringe against OPEC? Anybody? Well, the Brits were, for a start. The Brits, England started producing, Scotland, I should say. Britain, anyway, started producing oil in the North Sea. Lots of countries in Latin America started looking and finding oil. And of course, Russian oil started being very, very profitable. All right, so there are various reasons why it's hard to maintain this collusive agreement. One is there's an incentive to cheat, and another is that other firms are going to enter. But before we leave this, let's just pose the question we started with. Suppose, in fact, we do end up back at the Cournot quantity. So here we are back at the Cournot quantity. All right. How does this quantity compare, and how do therefore do prices compare, and how do profits compare with monopoly prices on the one hand and competitive prices on the other? All right. So we know the quantity that's going to be produced. We figured that out. Here it is. We know that the quantity is going to be produced. Each firm is going to produce A minus C over 3B, and there are two such firms, so the total quantity produced in the market, the total quantity will be 2a minus c over 3b. All right? How does that compare to the monopoly quantity? Well, the monopoly quantity was a minus c over 2b, and the competitive quantity was a minus c over b. Just to remind you of those, they're on our picture. Here's a minus c over 2b, and here's a minus c over b. So this is the total quantity produced in this equilibrium, in this Korno-Nash equilibrium. How does it compare to the monopoly quantity and to the competitive quantity? Anybody? A little bit of just staring at the board, which of these is bigger? So I claim that this total quantity being produced is less than the competitive quantity, but more in total than the monopoly quantity. All right? I was about to get that the wrong way around. That's right. Right? So the total quantity being produced is less than would be produced under perfect competition, but more than would be produced under monopoly. And consequently, prices are going to go the other way. Right? And consequently, prices are going to be highest under monopoly, lowest under competition, and somewhere in between in this Korno situation. All right? So from the point of view of the producers, this Korno equilibrium is worse than monopoly, but better than perfect competition. And from the point of view of the rest of us, the consumers, this Korno quantity is worse than perfect competition, but better than monopoly. All right? The only rider on that being if they're producing Coca-Cola and you have any kind of concern for your teeth, maybe you shouldn't produce so much anyway. All right. So far what we've done is we've looked at this kind of classic, I admit, not the most exciting game in the world, but a classic application of game theory to imperfect competition. Next time, I'm actually going to take this a bit further, but I'm going to leave this game behind and look at other ways in which we can study imperfect competition using game theory.